George, I really enjoyed the ride over here with you, and now we're just standing out here in front of the gorgeous spaceport and this beautiful terrain. You know, last time we were together, we were in Mojave. That's where you've been working and building the ships for the last 10 years, and maybe even longer probably. Yeah. And now you've begun to move your operations from Mojave to New Mexico. How many people are you going to transition? Are you going to keep Mojave open over once that's fully, or is it going to be 2 sites, or are you going to have a full transition to everybody who comes here?
So we're going to have about 150 people here, maybe a bit more, and we're moving 100 people from Mojave down to New Mexico over the course of the next few months. And then we'll retain pretty serious manufacturing capability back in Mojave, where we'll be building the spaceship. So that'll have many hundreds of people back there. So we'll really have like 2 locations. One is manufacturing the vehicles, and then down here in New Mexico is where we'll be operating the vehicles.
And how many total people are in the company working on this mission?
Well, we got about, I would say, order of magnitude 650 direct employees.
Are you going to continue to do R&D, research, engineering in Mojave as well?
Yeah, absolutely. So, the vision of our company is to start out doing these flights up to space and back from here. Right. But, longer term, what we really hope to do is to use the technologies of these spaceships and apply them to point-to-point travel. So we go high-speed point-to-point. We're actually the only company in the world flying people on Mach 3 journeys right now. Yeah. The only company in the world.
So I want to talk about the space profile, the actual. So you're going to have your astronauts, your future astronauts. And how many future astronauts do you have?
We have over 600.
600 people have signed up right now, and
yeah.
and they'll be the first ones to start going. And walk me through the flight profile.
Yeah. So first of all, you'll come down to Spaceport America here in New Mexico. 3 or 4 days before your space flight, right? And so you'll go through 3 days of training in the spaceport. So we're going to give you, everything you need to have the most incredible experience of your life when you go to space. And we're going to be telling you about how you move around the cabin, how, what to expect when you're going to be meeting your other crew members, the other future astronauts who are flying on the flight, and you're going to be learning about safety stuff, and you'll be thinking about, what do you actually want to do when you get up into space, and all that stuff. Right. Really important stuff. So you'll do that for 3 days, and then on the 4th day, you'll fly to space. And so what's going to happen is you'll have a really special moment when you're walking out of the spaceport, and we're going to drive you down to the end of the runway where the spaceship will be waiting. That morning, early in the morning. You get on board the spaceship. We're going to take off from this runway right here, go up into this beautiful New Mexican sky, and then we'll do a loop where we get the mothership up to the right altitude. So right. Getting close to 50,000 feet, a little under 50,000 feet. And then when we're almost quite close to being over the spaceport, not quite, but close to it, the vehicle will release from the mothership, so it'll separate out. The rocket motor will light, and you will suddenly be going very fast. Once that rocket motor lights.
How fast? What's the top
Well,
speed?
you get up to about you get up past Mach 3, but you're past Mach 1 in less than 10 seconds. So imagine, many cars go 0 to 10 and whatever. We're going 0 to 10 to Mach 1. Actually faster. So. Yeah. So that'll be quite exciting. And the pilot will execute a turn, so you're going straight up into space.
Right.
And then that rocket motor will burn for a bit, and then once it goes out, you will feel weightlessness inside of the cabin, like free fall, basically. Right. And so you'll be floating around the cabin. You'll be able to get out of your seat, experience the joy and the awe of weightlessness. But more to the point, you'll be looking down at planet Earth and, having that incredible experience of being outside of planet Earth, and everything that entails. And then, after a few minutes, the pilot will say, okay, get back in your seat. You get back in your seat, and then you'll re-enter right over the spaceport and do some loops, basically, gliding loops, sort of like the space shuttle. Right. And then you'll just come to a smooth runway landing here at Spaceport America.
Okay. So there's a mothership. So there's the mothership that's going to have the spaceship attached to it. The mothership will take off like a regular plane, sort of, right? Yeah. And although it goes much higher, it'll go up to 50,000 feet. Yeah. And then the ship is kind of attached below it. It'll release that that spaceship drops down,
Yeah.
and then just the rockets ignite right there,
Yeah.
takes off, and then does a complete or a really quick turn straight upward, right?
Yeah,
And just
exactly
shoots right into, breaks
Yeah.
breaks into what the atmosphere, or
Yeah.
breaks it, and then
Goes through the mesosphere, up through the stratosphere, and then up out into space.
and then that's when really the magic happens. Where they'll probably be like, the wildest ride you've ever been on, and then they're out there and they're looking down at the planet.
Yeah.
And in all of its magnificent beauty, and then there's this process, right? You have this design where like the feathers system.
Yeah, so basically we have this thing, it's almost like a badminton shuttlecock. So you know how like when you hit the shuttlecock, it always sort of points downward on the way down?
Right.
It's the same kind of principle. Basically the aerodynamics and the center of gravity orient that shuttlecock and also our spaceship so that it's always going sort of downside down,
Okay.
which is important because, re-entry into the Earth's atmosphere is always a crucial part of any spaceship journey, right? So what this does is it enables us to have a very stable re-entry back into the Earth's atmosphere. And in fact, the pilots could literally take their hands off of the controls and it would just re-enter naturally and safely.
Okay.
And then once you get back down into the atmosphere, so sort of 50,000 feet, then the wings sort of bend back down and it just becomes like a normal plane, like a glider, and it's just gliding back down to this runway here.
Right. And all this, the 15-year history and 9 years with Virgin Galactic. You've had solved so many engineering challenges, right?
Yeah.
Even when we're looking inside, you've got so many things just to move equipment around, and you have the simulators and you have the rockets. And what's been the most difficult thing for you to kind of deal with and solve?
Well, technically the biggest challenge was probably the rocket motor. So when I got on board here, we were having some significant challenges with the rocket motor. And so what we did was, we hired some really great technical experts, and they solved the challenges, and now it's working super great. It's just this very stable, very safe, very simple propulsion system. We think that there's a magic to simplicity. In general, simplicity is a pathway towards safety.
Yeah.
And because of that, we think it's actually probably the simplest human rocket motor ever flown, meant for human passengers.
Right. And that's part of your difference in your design, right? I think there's a little bit difference in what you did here with Galactic than what you did with your rockets and your ships at Virgin Orbit, right? And you were taking that safety. And
Yeah.
What exactly was that difference?
Well, when you're going orbital velocities, you need higher performance, and so what we did with Virgin Orbit is we built up new engines. They're really amazing. They're really terrific, but with that higher performance, you have to take some amount of greater complexity, and so we felt the right balance was for the basically the human spaceflight mission, we're using the hybrid rocket motors because they're simple and very, very safe.
Yeah.
And then for the satellite launch business, Virgin Orbit, we use higher performing motors as measured by a certain parameter of rocket propulsion that do have a greater amount of complexity.
If I remember correctly, on the ship itself, a lot of the material is carbon fiber.
Yeah, the structure is basically completely carbon fiber, composite material.
Right, and even the casing for the rocket, the engine.
That's right. Yeah,
Right.
I mean it's got a few different layers in it, but one of them is carbon fiber.
Right, and that's the only thing you can't reuse.
That's right.
The other interesting thing is, so you drop from the mothership, you drop the spaceship down, and then the rockets ignite and shoots out, and it goes up into suborbit, and then that's it. Like there's no more after that point. There's no more propulsion, right? It's kind of like the feather system brings it kind of back down, and then it just kind of glides in. Which I didn't realize the space shuttle was the same way. They just kind of glided back down as well.
Exactly right.
So then it comes back and then it lands, and then everybody's just had the ride of their life.
Yeah, that's exactly right. And one of the cool things about being able to turn off the rocket motor once we get to space is that it means we're going to have like this super quiet, really beautiful, peaceful experience when they're in space. Like the footage of our actual flights to space, which we did earlier this year, once that rocket motor ends, it's a very tranquil experience. There's a couple of hissing noises when basically we use these thrusters to orient the ship when we're in space, but once we're stopped using those, it's like super quiet, which I think will be a really amazing experience for our customers.
You had a pretty major setback about 5 years ago. One of your test flights didn't go well. It crashed.
Yeah, so we had an accident when basically our contractor, which was we were using a contractor at the time, and as they were conducting a test flight for us on the way up, there was a pilot error basically, and it caused an accident.
Right. What's the biggest lesson you've learned from that experience or that setback?
Well, I mean, you know, there are a lot of different lessons. One is that, you know, it's the responsibility of all of us. You know, safety is the responsibility of all of us. And we need to make a vehicle that, you know, we feel comfortable going on ourselves, right? And so, you know, I'm going to fly on it. My wife is going to fly on it. And for better or for worse, that test flight program is, or any test flight program is meant to be the way that you test that. Actually, you know, you can design the heck out of it, but until you actually fly it, that you sort of thought of everything. And so even though that accident was tragic and we continue to think about the folks who were affected by it, it made the ship safer, you know. And so, you know, the Gulfstream 650 had an accident shortly before it went into commercial operations. It made that ship safer. And, you know, and other vehicles have had accidents during the test flight program. And that's why, you know, we venerate test pilots, right? Because these are brave people, men and women, who put their lives on the line to make vehicles safe for other people to utilize. And so, you know, it's made me really appreciate the profession of test pilots, you know, and the importance of the test flight program. At each flight we do, we learn more, we make the ship safer. And so the goal is obviously by the time that we put that ship into commercial operations, that we feel comfortable with it and that we think it's as safe as it can be.
Right. You mentioned that you want to fly on it, you're going to take your wife on it. Yeah. I know Richard Branson, he wants to be, I think, one of the first people to do the commercial flights.
Yeah.
And that's, you know, I think that's a sign. I mean, you know, the accident, obviously, it's a reminder that what you're doing here is really hard. Yeah. It's really challenging. It's one of the greatest challenges you can have is space flight in terms of an engineering problem. Yeah. And safety is the most important thing. You mentioned earlier that the view for the astronauts will be about a 3 to 5 minute experience.
Yeah, that's right.
Do you plan to do longer in the future? Is that going to go long over time?
Yeah, I mean, I think, you know, we will over time potentially expand that a bit. The only thing that we're constrained by is we don't want the G's to be too hard on the way back in. Right. And so if you go up too high, then it might be a little uncomfortable for people inside. And so we want to measure that so that it's as high as we can reasonably go, but so that almost anybody can actually fly physically. Right. So that's the primary constraint. Now, once we start going point to point, we're going to be flying, you know, for an hour, you know, or something like that. So you'll have the amazing view for a while. If
you look out in the next 25 years or so, maybe even 50 years, what do you think happens if in space travel, especially now that it's become a private enterprise and it seems like there's a lot more movement into space? I mean, what do you see as the future?
Well, there's going to be a lot of really amazing stuff happening. I mean, number one, I think, obviously, parochially, I think it's going to be incredible that thousands of people are going to be able to go into space, right? So we're going to mint, other people will mint, you know, thousands of astronauts, right? So that's a really fundamental change because that experience of looking down on the planet, looking at the planet from outside, I think is a profound one, and it's going to have a big impact.
There's only been, about what, 500 people so far?
Exactly, like 571 or thereabouts have been to space. So which is a really small number when you think about it, right? That's not that many people who have actually been to space. So that's going to be a profound shift. NASA is setting out a program where we will go back to the moon and eventually to Mars. And so, you know, within that time frame, people will, I'm sure, go to the moon and Mars. You know, so the first woman on the moon, first man and woman on Mars, those will be really exciting milestones. And then I think, you know, another important milestone will be the further exploration of the solar system, primarily through robotic means. You know, we're going to be sending small satellites, small probes out to all the planets, all the moons of the solar system, to the asteroids and all that. And that's going to be profound because we're going to be able to build these probes for much lower cost than we have in the past, and they'll be able to fly all over the place, make amazing data measurements, and teach us a lot about the universe. The last thing I would say that's really exciting is that there's a lot of work going on in so-called exoplanets, which are planets around stars other than our own, right? Right. And so we have found now 4,000 planets around other stars, but that's just like the tip of the iceberg. Like we were talking about, there's billions and trillions and quadrillions of planets out there in the universe as a whole. And what we will be able to do over the coming decades is to start to detect biosignatures around those planets. You know, we can look at their atmospheric composition and we can see things like oxygen or methane or whatever. And in certain planets, that will be an indication that there is probably life there. You know, you can't say for sure, but you can say there's a very good chance that there's some kind of life. Now, it might not be like life like you that can build, you know, beautiful cars and spaceships and everything like that, but it would be some kind of life on other planets. And so I think within the next 50 years, I think that's very possible that we could make those discoveries.
You guys have been working on this for 15 years. You've been with Galactic for 9 years. What are you most looking forward to? What are you most excited about?
What I'm looking forward to most of all is, you know, we have this amazing collection of future astronaut customers, right? And these are people who have, you know, in many cases, dreamed about going to space for their entire lives. You know, for example, there's one lady who was actually sort of soft selected by NASA in the early years of NASA to fly to space, but wasn't actually not integrated into the astronaut program. So this is somebody who's actually been wanting to go to space for like literally 50 years, you know. You know, fulfilling the dream of those people, helping those people achieve their dream, you know, is going to be absolutely fantastic, right? You know, to have them do something that, you know, many of them thought that they would never have that opportunity, right? And we're going to actually make that possible for them. That's the thing that I most look forward to.
So look, hey, George, I've had such a great time with you today. I've had, you know, riding in the Range Rover and our chat on the way here and in this beautiful setting in New Mexico coming up to the spaceport. It's been time of my life, and you know, every time I meet with you guys and talk to you about it, I'm a little closer to like to wanting to sign up myself.
Do it. It's gonna be great.
Hey, thank you so much again.
Thank you.
It's been really a pleasure. A lot of fun.
It's been a lot of fun.
All right.
Appreciate it.
Let's go ride back.